guys, hope you're doing great. Our today's question is largest rectangle in histogram. So the question says, given n non-negative integers representing the histogram's bar height, where the width of each bar is 1, find the area of largest rectangle in the histogram. So this is the given histogram represented as an array of the height of the bars. The answer is this, which is 10, which is 5 into 2, because each bar's width is 1, right? So clearly, if we would have included, for example, 1, the maximum height we could have taken would be 1, right? So, and for example, if we would have taken 5, 6, and 2, then the maximum height we could have taken in this rectangle would be 2, because 2 is the height which is common to all the bars that we are considering. So that makes it clear that if we have n bars, then the rectangle that can be formed using those n bars, the height which we can take will be the least of the n bars, right? Okay, so this is an unsorted array, and we have a couple of techniques that we have listed down to be able to solve unsorted arrays. So please pause the video, have a look, and come back. So I think this is pretty easy, right? We can use a collection in order to store the group of members that we want from the array, right? Which basically reveal our largest rectangle in the histogram, and we can just use whichever collection we feel would be apt in this particular question. So this would be the technique that we would go with to get the answer. Right. So talking about which collection we should use. So in this question, we clearly know that at any particular bar, we cannot define the maximum area looking at just that particular bar's height. So we need to know whatever elements we have traversed in the past, so as to determine that what is the maximum height that we can store, or maximum height that we can use to be able to determine the maximum area of the rectangle, right? So in such cases, stack is always handy. So that would be our collection. And another thing to note here is that if we get a bar with a height lower than what we have in the stack, then it means that we have some bars with a more or a better height than this one, and because there is a lesser heighted bar coming, it would basically reduce the height of the rectangle that can be formed, right? So it's always better that we calculate the height or the area using the previous heights that we have seen, right? So that's what we'll be doing. Whenever we see an element whose height is less than what we have stored in the stack, we'll remove all the elements from the stack until we get an element which is less than this particular current bar, or the stack becomes empty, right? If we see a bar with height more than what we have right now, we'll add it to the stack. We'll keep adding, and whenever we get a smaller one, we'll calculate, or if we are exhausted of all the bars, we have gone through all the elements in the array, then we'll calculate. Okay, so that's the approach, right? Also, we'll be storing the indexes in the stack, because when we do the math to calculate the maximum area, we need the indexes to be able to understand how much width are they covering in the histogram, right? So that's why we'll be storing the indexes. So I'm sure we'll write the solution and it will be better. So let's quickly get started. Okay, so base conditions first. So if heights dot length equals 0, then we have to return 0 because we have no bars. If heights dot length equals 1, then we have to return heights of 0 because that's the only bar, so that's the maximum height. Okay, now we need a max, and that's 0. This is the maximum value that we'll be returning at the end of the function. And we take a stack, as I just told, to store the indices. Sorry. Okay, so to the stack we just add 0. Okay, that's the index. Basically we are adding the first element, elements index, and now we write down a simple for loop. So we start from 1 because we have already added, right? And less than heights dot length I plus plus. Okay, so let's get the current element we are dealing with, which will be heights of I, right? That's the current value. And so if the current value is less than, or let's go by the simpler one first. So if it is greater than or equal to the heights of stack dot peak, right? So we have the index, right? So that's why we just look at the stack and we see, is this current bigger than the bar whose index is at the top of the stack? If yes, we just add this to the stack, this meaning I, right? Otherwise, what we have to do is that while the stack is not empty, okay, and current is less than heights of stack dot peak, so the same stuff, right? But only that while the value current is lesser than whatever we are seeing in the stack. So we just want to pull out all the elements, right? So what we'll do is that we'll just get the temp in a temp variable. We'll just get heights of stack dot pop this time. So we are removing it from the stack, okay? Right. And yeah, so in order to understand what is the range, we are, for example, I is 0, 1, 2, 3, 4, okay, and we just popped out this particular index, which is 3. So what we'll do is that we'll do a 4, right, minus 3, right? So what we're doing is we basically want to understand how much is the width. So what we'll do is that we have to do a 4 minus what is on the stack before this and a minus 1. So that will basically give us the length. When we'll pop 5, then at that time 4 minus prior to this, if we'll have like 2, then the index of that, and if the stack becomes empty, then we'll just multiply it by I, assuming that is the smallest heighted stack, and we'll just get the entire area that it can form. So what we'll basically do here is that if the stack is empty, okay, because it could get empty because we have popped an element from it over here. So if the stack is empty, then we just say that max equals to math dot max of max, right? And we want to multiply temp, so we are trying to find the area here, into I, okay? So whatever index this is at, we'll just use that. For example, when we get a 1, we'll have the 0 on the stack. So we'll do a 1, which is the index for this, minus, so after we pop this out, it will be empty, so we don't have anything. So we'll just do a 1 into the area of this, the height of this 2. So that will give us 2, which is actually the maximum area that can be formed using this. Okay. So, right. Else, so if the stack is not empty, then max equals to math dot max of max, comma, temp into, so as I said, I minus stack dot peak. So we are not removing the element, we're just looking at what is there to get the lower end of the boundary, and minus 1. Right. Okay. So we do this, and after we are done with popping out all the elements, we have to add this, right? So we just add it to the stack. Okay, cool. So we're done with this loop now. Now it is a possibility that in the given histogram, we could get values like, for example, 5, 6, 7, 8, 9, 10, right? So in that case, we'll never see a bar of a lower height, and we'll just keep adding them in the stack because of this for loop, and we'll just exit out of the for loop, right? So we would not return the right answer if we do not check this after completing the for loop, that if stack is not empty, okay, if the stack is not empty, oops, okay. So now, similar to this, we just want to basically imitate whatever we have done above over here. So what we'll do is that we'll just, for the brevity's sake, I'll just copy this. So we don't need this because we don't have new elements coming or anything like that. We just know that there are elements which have not been processed in the stack, right? So until the stack does not become empty, what we'll keep doing is that we'll keep removing one by one elements and then just keep calculating the maximum area that we can form from them. So I in this case is heights.length because the elements of the array heights have all been traversed, and since here for I we calculate the previous one and minus the boundary on the other side of the array, we were just taking this plus 1 to make the same calculation. Okay, so I guess that should be it. Yeah. Okay, and then we just have to return max from here. Yeah, let's see if that works. Okay. All right. So the time complexity for this is O of n because each element is being pushed into the stack once and being popped from the stack only once. So it's O of n. Space complexity is O of n as well because we're using a stack to store all the elements. So I hope you guys find this video helpful. Please comment in the section if you want me to create any videos on specific questions, and I'll try to make them as soon as possible. Please like, share, and subscribe. Keep coding and take care, guys.